So here we are at compound interest. We're looking at video 4 of compound interest. Want to make sure you have a copy of your handout and a copy of your formula sheet. We're going to do some calculations for finding I. When we find I, we always have to convert it to an annual rate. So if I did this formula and I found out that I did this calculation and I equals 0.01 and it was compounded quarterly, you would multiply it by 4 to get a 4% annual rate. Next example, if I did this formula and I got I equals 0.03 and it was semi-annual, you'd multiply it by 2 or your answer would be 6% annual. If I did the calculation, I got I equals this number and it was monthly, you multiply it by 12 and get a 5% annual interest rate. The last one I'll cover is daily. If you do the calculation of I, get this number and it's daily. Remember, we'll almost always use Banker's rule and you multiply it by 360 for a 6% annual interest rate. Now let's look at when I give you in the givens, it's future value, present value, and the interest rate. You will turn the interest rate into an interest per period, I. Do this calculation with log. So, if we do this calculation and n equals 19, and the interest is compounded quarterly, you need to give me the answer in years, months, and days, if necessary. You take 19, and since it's quarterly, you divide it by 4, and you get 4.75. This is 4.75 years. You pull out 4, the whole number 4 for 4 years, and then you take 0.75 and multiply it by 12 months, and it comes out to an even 9. So this answer would be 4 years and 9 months exactly. Next example. N equals 7 and is compounded semi-annually. Since it's semi-annual, you divide by 2 and you get 3.5. You pull out the 3 for 3 full years and you multiply 0.5 times 12 and you get 6 months. Next example. N is 170 and it's compounded monthly, so therefore the first step would divide it by 12. I have 14 whole years, and then I take the decimal portion here and multiply it by 12, and I get approximately 2 months. There is a round off error because I only went to 5 decimals here. The last one, N equals 1,110, and it's compounded daily, and we're going to use Banker's rule. To be consistent, I divide it by 365 days because it's daily. I receive 3 full years. I pull out 3 full years. Then I take this decimal portion, multiply it by 12, and you'll notice it's 0 here. So that's 0 months. Now I take this decimal portion, and we always multiply by 30. We assume 30 days in a month, so I multiply this fraction, this decimal by 30, and I get 14.79 days. We always round to 15 days. So if N equals 1,110 and is compounded daily, your answer to me has to be in years, months, and days. There's a homework. I'm going to skip over this one. We've done this one. It's just practice. Practice putting it in your calculator. You're welcome to do that. Same here. And this is the first one on your handout. Again, I give you 5 years, 7% compounded daily, and I ask you to find future value. I want you to calculate IN and confirm present value is 120. So this is just practicing, put it in the calculator. I'll point out a couple of mistakes. In the formula to calculate I, make sure this exponent is in parentheses. Okay, I didn't have to do it here, but when you put it in your calculator, you have to. So, we got an interest rate of 0.00019. Cannot leave it in that form. You multiply it by 360 and you get 7% interest. Again, when we solve for n, given future value, present value, and I, we got 1,825. Do not leave it in that form. You divide it by 365 because it's banker's rule, and you get 5 years. So interest rate is 360. Term is 365. One B, I'm going to let you pause and do by yourself. It's practicing solving for I and then converting it to an annual interest rate. Here, 1C is practicing calculating N, getting N, and converting N to years. The next several problems are practicing I and N. And I'm going to go through them quickly. I recommend that you pause and do them all. And you might want to, when you do something like find I found I was 0.01539. That is the interest rate per period. Or in this case, it's the interest per month since we're doing monthly. We don't leave it like that. We need to calculate it per year by multiplying it by 12. So this is 18.47 per year. And I'm going to allow you to do this. Converting 68.857 is our N. That's the total number of months when we did this calculation. We need to turn 68 whole months into 5 years and 8 months. I'll give you a second to calculate that. Then we have 0.857 of an entire month. We multiply that by 30, and we get approximately 26 days. So our answer is 5 years, 8 months, and 26 days. This is an equation of value where we're making a prepayment. We've done these. We sign a note for $8,500. After a year, we make a payment of $4,200, and this tells us the focal point or where we have to equate all our money values at 18 months. So we have to find what does $4,200 in 18 months, what's that value? And we have to find a future value as $8,500. So both of these, we find future value. We have to calculate an I and an N for each of these. I will remain the same, and there's going to be two different N's. N for the 4,200 is 2, and for the 8,500 is 6. It's per quarters. There's 4 quarters in a year, and then there's 2 more for a total of 6. We need to calculate 2 future values. One for 8,500, one for 4,200. And here is the calculation for compounded quarterly. If we subtract those two, then at the 18 months, we owe $51.4323. Now, in compound interest, we can do it like merchant's rule. We can find the future value of $8,500 at 1 year, which is $91.55.65 right here at 1 year. We make that payment of $4,200. So we only owe after 1 year $49.55.65. And then we bring that forward to a future value where n equals 2. And we get the exact same number, 51.43.23, where it was different in simple interest. Remember merchant's rule, U.S. rule? In compound interest, if we buy and sell right at the beginning of a period, or in this case the quarter, they'll be the same. One of the favorites. The lender agrees to settle with 2 equal payments, 1 year and 2 years respectively. What are the payments based on 9% compounded annually? So we owe $50,000 today. We're going to pay half of it in 1 year and part of it in year 2. But these X's are going to be the exact same amount. So we have 3 different times here. We've got to equate them all at one focal point. I've chosen now as the focal point because $50,000 is how much we owe now. So I've got to find the present value of this X and the present value of this X. X will remain the same, but their present values are going to be different because this one only had a year of interest and this one had 2 years of interest. So I'm going to turn this X into a present value. So the present value of these 2 X's added up will be 50,000. So here, this X, the present value formula is right here. X divided by 1 plus IN. This present value formula is X divided by 1 plus IN. Now we have to find I and N for each of these. I will be the same. It's 9% divided by 1. N will be different. I want you to pause this and calculate N for this X, and we'll put it here, and calculate N for this X and put it there. There you go. So I did it right here. N is 1 and N is 2. Now, in this formula, we can't combine them because the denominators are different. We are going to factor out the X. I'm going to pull the X out, and I'm going to put 1 here. I'm going to factor out this X. I factored out this and put 1 here. Now, I want you to pause it and do this calculation right here. 1 divided by 1 plus 0.09 raised to the 1 power. And I want you to do this calculation on this fraction. 1 divided by 1 plus 0.09 raised to the 2 power. When you do that, you have X times 0.91743 and X times 0.84168. You add up these two, and it should be 50,000. So we can add this coefficient to this coefficient, and we get 1.75911. Now we do a little bit of algebra. We divide both sides by 1.75911. This cancels out, and we get X to be 28,423.46. So we owe 28,423.46 here, and 28,423.46 here. You cannot just split 50,000, 25,000, and 25,000 because this, they've generated interest. This is generated it for interest a year, and this is accumulated interest for 2 years. So these, rule of thumb is these 2 X's, if we're going to have a focal point now, these 2 X's added up together will have to exceed 50,000 because they've accumulated interest. So the answer, 28,423.46, makes sense. and an estate is worth 458,000, is left to two children, age 12 and 16. If the money is invested in a fund paying 5.5% semi-annually, and the two heirs are to receive equal amounts at 21, how much will each child receive? So I calculated I, which will be consistent, N will be different for the two children because the 12-year-old has to wait longer. The 12-year-old has to wait 9 years to be 21, and the 6-year-old has to wait 5 years. We want to know what's the present value, and because of that, we calculate an N for each child. So here's very similar to the previous problem. So now we have 458,000. We want to find a present value of the oldest child. This child only has to wait 5 years. The youngest child has to wait 9 years. So N for the oldest child is 5 times 2 is 10. The youngest child, 9 times 2 is 18 periods. So now we have to calculate a present value of oldest child plus the present value of the youngest child. I want you to pause it and try to create the equation yourself based on the previous slide. These two present values will equal 458,000. So here we are again. X for the oldest child. This is the present value formula. Here's I raised to 10. Here's 10. The present value for the youngest child, here's X, is X divided by 1 plus I raised to the 18th because they have to wait 18 periods. Once again, we factor out the X. We factor out the X. I want you to practice calculating this fraction, calculating this fraction. When you do that, you get this decimal and this decimal. I'm going to drop the O and the Y because they're really going to be the same number. And we add the coefficients. We do a little algebra and divide this coefficient by this side of the formula and this side of the formula. So we're left with X here, and each child, when they're 21, will receive $332,834.09. Here's another equation of value. You will sell a piece of property for $50,000. The buyer pays $20,000 cash down and signs a non-interest-bearing note for $10,000 due in 1 year and a second non-interest-bearing note for $10,000 in 2 years. If you charge $10,000 compounded annually, what will the non-interest-bearing note in 3 years be? Oh, non-interest-bearing. Remember that? Well, the first thing we do, we buy it for $50,000 and we pay down $20,000. So calculate our present value we owe. We owe $30,000 right now. We said we are going to sign a non-interest-bearing note for $10,000. So that means we owe $10,000 in 1 year. And then a second year, we're going to pay another $10,000. If you charge 10% compounded annually, what will your last payment be? It will not be $30,000 because you've accumulated interest for 3 years that you owe them. So it's going to be more than $10,000. Before you start a problem, see if you can use common sense what you expect an answer to be. I expect this to be more than $10,000. I have to find the present value of this $10,000, the present value of this $10,000, and the present value of X, and they've all got to equal $30,000. Okay? You can't just say, oh, 30,000 minus 10,000, 30,000 minus 10. No, this 10,000 had a year of interest. This 10,000 had 2 years. So you've got to equate them all now. The focal point is now. So here are 3 present value formulas. They have the same I, but N is going to change. Again, factor out this X, calculate this fraction, calculate this fraction, factor out the X, and confirm what I have here. And your last payment is going to be $16,830 right here. Much more than $10,000. I want you to pause, but I want you to do this problem quarterly instead of annually. So there's 4 periods. So N here is going to be 4. N here is going to be 8. N here is going to be 12. Three children aged 19, 16, and 14 are left a sum of $30,000, of which they are to receive equal payments when they reach 21. The fund is invested 8% semi-annually. How much does each child receive? So what I recommend in a complicated problem like this, 30,000 is going to be the focal point, or now is going to be the focal point. But for each of these children, calculate an N. I is going to remain the same, 8,000 divided by 2. But N is going to be different. So I want you to pause this and calculate N. And for the 14-year-old is 14, 16-year-old is 10, and then 19-year-old N is 4. So I want you to set up a timeline and an equation to value a present value for each child. Here's your present value formula. All 3 of these should equal 30,000. Factor out the X and calculate the fraction. Add these 3 coefficients. Do a little algebra, and each child receives $14,232.56. Let's look at the payout to each child. Let's see if we end up with 0. Let's see if that previous slide was correct. So we have these 3 children. We have 30,000 now. We are going to find the future value of 30,000 at 2 years when the first child, the 19-year-old, becomes 21. So a future value of the 30,000 is 35,9576, okay, at 2 years. Well, we've got to give that child their inheritance. We subtract out that $14,232.56. We paid it out to them. So we have $20,863. After the payment to the 19-year-old, we have $20,863.20. We find a future value of that at 5 years when the 16-year-old turns 21. That future value is $26,398.60 at 5 years. Well, now we owe the 16-year-old, who is now 21, his $14,000. And we have $12,166.04 left after we make that payout at 5 years. We find the future value of that for 2 years or 4 payments, and that equals $14,232.56, which is the last payment, and we end up with 0 in the bank. Okay? So I'll let you pause and confirm that the payout is correct. Let's look at another type of problem. You want to buy a boat. Plan A is to buy the boat for $10,000 down and pay $5,000 in 4 years. Oh, and you can take your money and earn 7% compounded quarterly. Plan B is to pay it all up front now at $14,000. So we've got to equate all money now. So here we have $10,000 down, and we can pay $5,000 in 4 years. So we've got to find the present value of that $5,000. We've got to find the present value of the $5,000. The present value of $5,000 is $3,788.08. Well, we've put down $10,000, so we're going to add $10,000. So Plan A only cost me $13,788.08. Plan B was to pay $14,000 up front. We're equating all the money right now. So Plan A is better. I saved money. I didn't pay $14,000. I paid less than it. So Plan A is better. Let's change the interest rate to 5%. Same exact problem, but instead of 7%, money's only worth 5%. We're going to equate everything for now. Right now, our focal point is now. When we do it that way, when I do it this way, Plan B is better. Today you owe $20,000 due in 3 years, 10% compounded quarterly. Additionally, you owe $10,000 due in 5 years at 8% annually. If money is worth 9% annually, what single payment in 6 years will be equivalent to the original obligation? So I owe $20,000 in 3 years. Okay? I'm going to find that future value. $20,000. I signed a note 10% quarterly, and 3 years times 4 n equals 12. So I am going to owe that $20,000. I'm not going to owe $20,000. I'm going to owe $26,897.78 in 3 years. Additionally, I have $10,000 that I owe in 5 years. So let's find that future value. Nope. I'm going to take a step back. We're going to pay it off in 6 years. So I'm going to take my $20,000, which at 3 years turned into $26,897.78. I'm going to find its value at 6 years. So 1, 2, 3 more years, but now it's compounded annually. So this $26,897.78 at 6 years is worth $34,833.41. So $20,000 now in 6 years, $34,833.41. Now let's look at the $10,000. I'm going to owe $10,000. I have $10,000 in 5 years. I need to pay back $14,693.28. But I know I'm not going to have the money. I want to pay it off the 6 year when I sell the business. So I find a future value for 1 more year is $16,015.68. I combine those two debts. These two debts. So on the 6 year, I can pay it off for $50,849.09. Now, the last thing I want to talk about is continuous compounding. Now, we talked about compounding it annually, or monthly, or quarterly, or daily. There are some banks that actually have continuous compounding. So let's go back and look at 5% quarterly. And if you remember our effective annual interest rate, that really is a 5.09 annual rate. If I look at 5% monthly, it's 5.116 annual. If I do it daily and use this formula, it's 5.126. So you can see I'm getting higher and higher interest rate. Well, what happens if I say it's continuously compounding, infinitely compounding? It should be something more than 5.126. Here are all the formulas, which you can write down on your formula sheet. And for example, I said 5% daily was 5.126. Continuously, it moves that up to 5.127. So believe it or not, continuously compounding does not increase the interest rate that much. But here are all the formulas to determine future value, present value, the rate, and the time in continuous compounding. And what I'd like you to do is pause it and go through these next examples and calculate the continuous compounding. So, we finished the fourth video on compounding interest. We are going to expand on continuous compounding by looking at annuities or mortgages, maybe 529s. You might be familiar with those. Your parents probably invested some money with those. You're welcome to stop the video now. Please do your homework. Please fill out your handout, and we'll see you next time.